Okay, getting back to solving how much PABA we need to get 10 millimoles of para-aminobenzoic acid, so PABA. So we want 10 millimoles per liter of para-aminobenzoic acid. We know it's going to be more than we know it's going to be more than 5 beta. We're going to need more than 5 millimoles of beta cyclodextrin. So we're going to put 10 in here because that's what we want. We need to solve for how much beta cyclodextrin we're going to get. We've already worked out the problem, right? We know that in order to get 10 millimoles per liter of the drug, we know the innate solubility is 1.246 millimoles per liter. We know the slope is 0.982 here, and we just need to then solve for the concentration. So what concentration of BCD do we need? Well, we need to just rearrange this equation. So it's going to be, to solve for concentration here, we're going to take the drug concentration that we want, so PABA concentration, and we're going to divide that by, well, first we're going to subtract the y-intercept here, right? We're going to bring this over to that side. So the PABA concentration, this indicates concentration. So PABA concentration that we want to get, minus the innate solubility here, so D0, and then we're going to then divide that. So we're going to put some parentheses around this whole thing. We're going to divide that by the slope of the line. And that will leave us with just concentration, which is what we want, right? So what concentration of BCD we need? So the concentration of BCD is going to be equal to the concentration of PABA. So we're going to say equal to the PABA concentration, which is 10, minus the innate solubility, which is this number here or this one. They're the same thing, right? Now we're going to put parentheses around that one because we want that to happen first. And then we're going to divide that by the slope of the line. So there's the slope of the line. And that tells us what concentration of beta cyclodextrin we need. So there's our answer. We need 8.91 for millimoles per liter of beta cyclodextrin. We have to add that in order to get 10 millimoles per liter to go in the solution. So there's your answer. Okay, so do you think you can do this on your own? Let's try it. So see if you can put these in and get the same numbers I did. Okay? And then I'm going to give you some more practice problems to work on. Okay? Great. And some other questions to answer. Oh, and I probably should have shown you this slide first too. Let me just change this. So we're sharing the right thing here. So this is that beta cyclodextrin on the x-axis, PABA concentration on the y. We get the slope of this line, and here's the equation of the line. Y, which is a PABA, equal to the slope of our line, 0.981, times the concentration of the PABA concentration that we have, plus again the innate solubility. And this is a straight line, so the r squared is 1 here. All right, so slope, y-intercept is the innate solubility. Slope is needed to determine the Ka and to determine the relationship. So in this problem, I want you to see if you can do the y-intercept, which is the innate solubility, the slope, which is right here, and then see if you can determine the amount of BCD needed to dissolve 5 millimoles of PABA. So 5 millimoles of PABA is going to be somewhere between 3 and 4 millimoles of beta cyclodextrin. See if you can solve that on your own. All right, that's all for now. Bye-bye.